So as I mentioned, so our this bottom parsing, we are going to start from our input string, and it will work upwards to reach the root node, that is our start symbol. Okay, so in bottom up parsing, we have to work with our input string, and we'll try to derive the start symbol. So in bottom up parsing, we can say that our bottom up parsing follows the rightmost derivation in reverse order. Okay, so what you can understand from here is rightmost derivation in reverse order. Okay, so bottom up parsing means rightmost derivation in reverse order. So let's see this example, then you understand it. So here is your example. Here we have this tree grammar. Okay, tree production. The first one is S tends to uh, A, then capital letter A, then B, capital letter B, then E. Okay, so and we have this tree production. So what is the start symbol over here? S is our start symbol. So given this tree production, where S is our start symbol, and we have our input. So input string is given over here. So we have our uh, given input string. Just a second, the trains are coming. Just we'll wait for 1 2 minutes. So we have this tree production, that is S tends to this, then A, then B tends to this. Are three production that we have, where S is our start symbol, and we have the given input, that is A, B, B, C, D, E. So this is our input string. So how we can derive this input string, or how we can generate bottom up parsing uh, with respect to this particular input is being discussed over here. So our aim here in bottom up parsing is we have to take our input string, and then we have to derive to our start symbol. Okay, so considering this input string, that is uh, A, B, B, C, D, E. Okay, this is our input string. Then our main aim is to derive our start symbol S. So considering this input string, so we have to derive whether the first one string is A, whether we can derive A to anything, means whether there is any production that gives uh, uh, only A in the right hand side. So there is no right, so we leave it. Then next is B. So if we consider B, we have a prediction that is A implies B, or A implies B, this production. So using this production, we can replace B with A, right? Then can we derive again B to A? We can, but what is our aim? Our aim is that it must we must try to derive to S. But when we try to derive to S, we must try to get this string, that is small letter A, capital letter A, then small capital letter B, then E. So if we again convert over here, then we won't be able to do this one. So So in the first step, we just derive our this small letter b with the capital letter A using this production. Okay, whatever that is highlighted or bold uh, in the string, we just derive it. Okay, so instead of B, we can use A using the production A implies B. Again, from the, again, then if we take this substring that is being bold, then and using this production that is A implies A B C, then instead of this bold, we can just replace with A, right? So it returns small letter A, capital letter A, then D E. Okay. So next is we can derive this D using this production. B implies D. Okay. So instead of D, we can replace it with B. Right. So what do we have? We have small letter A, capital letter A, then capital letter B, then E. So this string can be derived by S. S implies this one. So at last, instead of this, we can reduce to S. Right. So in this manner, we are going to work our bottom up parsing where we use the input string and the and derive to the touch symbol as okay. So so whatever at every step we we change some symbol with using this derivation. So whatever that is being bold here or that is being changed or derived is what we call it as handle. Okay, so handle. So here in the first case, b is our handle as b can be changed to a using this production. Okay, so handle is nothing but our substring matched with the right side production. Okay, so in this first line of the production, b is our handle. In the second, a, then in third, abc, then in fourth, d. In last, it's a complete string. Okay, so just I'm giving you a few seconds. Just see whether you can understand it or not. If you don't understand, just tell. So uh, I assume everyone is okay with it. So we have mentioned that it is the rightmost derivation in reverse. Okay, let's try to find out with the rightmost derivation. So if you, when we're talking about rightmost derivation, we have to start with the given production that starts symbol production. Okay, so if you consider this first line of production, and if you want to derive this input string, so this is our step. Okay, so when we're talking rightmost derivation, we're going to just we're going to change our non-terminals to terminals, right? Or non-terminals to variables. So here rightmost uh, that is B has been changed to D, and then the next rightmost is A, so A has been changed to this using this production, and then we have again A. So only with this three step we got our input string. Okay. So here we were just shown the rightmost derivation way of getting this input string. Everyone just see this rightmost derivation and just if you have doubt tell me else. So if you look over here, this is our rightmost derivation and here is our top down parsing. Sorry, bottom up parsing. Okay. So if you compare this to just see what is the thing similar. As the name suggests that our bottom up parsing is rightmost derivation and in reverse order. So just see whether this rightmost derivation, if we do it in reverse way, we get this bottom up parsing. Just see. So look here. So the last step in your rightmost derivation is our first step in this bottom up parsing. Then the next second last is happen to be second step in our bottom up parsing. Then again next step is again next, and it keeps going on till we get the start symbol in the bottom up parsing and starting symbol for the rightmost derivation. So if you compare these two way, we find that our bottom up parsing is nothing but our rightmost derivation in reverse order. Okay, so that's why it says that our bottom up parsing is nothing but the rightmost derivation in reverse order. And here is just a pictorial form of our this bottom up parsing. So it's just a pictorial form of this derivation. So first, what do? We replace with b with a, then the next one is we take ABC, capital letter A, B, C, D, and we derive it or we reduce it to A. Okay, we reduce it to A. That's our next step. Then next step is we replace B with D. That is our next step. And the last step, so taking consideration of all this, we get S. Okay, so this is just a pictorial representation. So this bottom-up parsing, we also call it as SIB-reduced parsing. Okay. So whenever there is a term like SIB-reduced parsing, it refers to this bottom-up parsing. Okay. And this, but LR parser are bottom-up parser, where we have different types. So few of them are given here: LR parser, then SLR parser, then LA LR parser, then CLR parser. Okay. So here LR and SLR, they are going to work with some item called as LR0 items, whereas this LA, LR and CLR are going to work with some item called as canonical LR items. So in short, we're going to work, if we understand one, it is very easy to understand the remaining. So I think if you have seen the LR0 notes with videos, then it's easy to understand SLR1 as well. Okay. it's, it's pretty much similar with uh, LR0. So what you can understand from here is when we're talking about bottom up parsing, we have to start with input string and we have to derive to the start symbol. Okay, we are going to construct our parse tree beginning with the input string and we must derive to the start symbol. Then, uh, so we'll check the substring with the right side of the production Okay, with this we'll check the substring with the right side of the production, and if we found any match, then we are going to replace the left side of the production, and the match substring is what we call it as handle. Okay, that substring which match is called as handle, and the process of like replacing is called as reduction or reduce. Okay, so as I mentioned before, that your bottom up parsing is also called as shift reduce parsing. So what is this shift and reduce? As it's going to consist of these two steps. So the first one is the shift step refer to the advancement of the input pointer to the next input symbol, which is called as shift symbol. So it simply means that we are going to go to the next symbol after checking one symbol. That step is called as shift step. And reduce is, as we mentioned before, if we find any match, mm, if we find any match substring, then we are going to reduce it, right? So when the parser find a complete grammar rule that is in the right hand side and replace it to left hand side, and we call it as reduce step. Okay. Then this is our LR parser. So what is this LR parser? So LR parser is nothing but non-recursive shift reduce bottom up parser. So here the first L stands for left to right scanning of the input stream. Then R stands for rightmost derivation in reverse. And you may have found K, which denote the look ahead symbol to make decision. So we have LL, zero refer mean zero means there is no look ahead symbol. And when we're talking about SLR1, then we have to look for the next symbol as well. So we have SLR1 because look ahead symbol is 1. Which whenever we are checking, we are not going to just stop with a symbol. We are going to check the next symbol before confirming. Okay. So in top-down parsing, we have LL, and in bottom-up parsing, you have LR. Okay. So this is just the difference. I think this is just a theory thing. You can just go through it. Okay. So this is just difference between LL parser and LR parser. Okay. Mm. So I assume that everyone is familiar with uh, LR0 parsing. Okay. So we're going to discuss SLR1 parsing. Okay. So it's pretty much similar with LR0 parsing, as I mentioned before. So, SLR1 refers to simple LR parsing, and 1 here refer means look ahead is 1. So as it's even given here that it is same as LR0 parsing. The only difference is in making parsing table. Okay, so the concept is similar, only the difference is making of parsing table. And here we place the reduce move only in the follow of the left hand side. So the main difference is SLR1 and LR0 parsing is that in SLR1 we're going to put the reduce only on the follow of the left hand side variable. Okay. So in LR0 parsing we we place the remove move to all the available variables, but here in SLR1 we are going to place it only to the follow of the left hand side. Okay, we are going to place the only on the follow of the left hand side. So the step also similar. So other thing is, so main step as usual. Okay. So as usual, we are going to include our augmented production in the grammar. Then we have to create a canonical collection of our LR0 items. Then we have to draw this DFA. Then we are going to construct the parsing table. So if you gone through the LR0, then you find that it is similar with that one. So given this grammar, okay, so here we have this given grammar that is S implies to capital A, and we have the second production that is A implies to small letter A, capital letter A, and then we have the third production that is A implies to B. So given this grammar, the first thing is we have to add the augmented production that is augmented grammar S just implies S. So whenever we say augmented production, we have to include a production of the form S just implies S, where S is the start symbol. So in this case, S is the start symbol. So this is our augmented grammar or augmented production. That is S just implies S. If our production start with Y implies something like Y implies AA, then the augmented grammar is going to be Y just implies Y. Okay, so the first step, as usual, is to include the augmented production or augmented grammar. Then the next step is making of this LR0 items. Okay, so how we are going to make LR0 items? We are just going to insert a dot symbol uh, in the right hand side of your production. Okay, so this is our grammar. If we include the augmented production, then it becomes what? Yes, just plus, then it implies A, then A implies A, A implies B. Okay. So this is our reduction on inclusion of our augmented grammar. Okay. So for canonical collection of LR0 or LR0 items, what we're going to do is we're just going to place the dot symbol. We're going to place the dot symbol in the right hand side. Okay, so dot symbol in front of S, dot symbol in front of A, dot symbol in front of, so over here. So this is our canonical collections of our LR0 items, or LR, just these are our LR0 items. Now once we have this LR0 items, once we have this LR0 items, now we have to draw the DFA diagram. Okay. So to draw this diagram, what we are going to do, we are going to use the function of go to and closer. Okay. So in LR0 items, it has been included that you can have these two functions, that is go to and closure function. So so the first one is our canonical collection of zero items, a large zero item. This is over here. S just implies dot s, then s dot a, then a. So this is our for production that we have. Okay. Then we'll just considering this first case. So if we consider this go to, then again we have this closure where we give the dot to the next after the symbol. So here we have dot in front of s, then here the dot will go to after that. So whenever we have dot after the symbol, it means that it's the final item and there is nothing to be done with it. Okay, so this is our first one where we read out our closure. Then next is if you consider the second one, then we consider go to, then we consider closure over here. So this, so here what it becomes, we have, so s derives a dot a. Okay. Once you have this uh, dot in the next after the variable, it becomes this. Okay. Still we have to carry out closure property function as after dot there is some symbol. Okay. So after dot we have a, so we're going to bring this a implies dot a with the letter a slash dot b. Okay. So we're going to bring the production of the next symbol after the dot, that is a. Okay. So it becomes dot a plus dot b. So the production of a. Similarly, if we consider the next one, that is a, here a dot a. So here we have to bring the production of a again. So these two production as we do over here, we bring the production, that is a implies dot a with the letter a implies dot b. Okay. Then if you consider b, it's b dot. So nothing has to be done over here as there is no other item after dot, and it's the final item. So after this, the next is if you consider for this so we just give uh, the numbering. First one is there as uh, I node, then I1, then I2, I3, I4. So with I1, since it's the final item, we don't have to do anything. But when we are talking about I2, we have elements or variable after dot. So the dot means what we have to do. We have to do again go to. So if we do go to over here, so we do go to of a, then it becomes s plus a dot, and it becomes our final item. So here if we do with dot a, okay, if we place the dot after small letter a, then it gives the same as the I3. Okay, and if we do give the dot after b, then it gives this state I4. So we just point it over here. Okay, and with that it's done with I2. Then with I3 again, if we do dot with the fast production, that is a dot, then it again also becomes the same thing with this production. so it points to itself again. And if we go with this B, then it becomes this projection that is uh, um, the state I4. Okay. So with this, then if we consider about this go to with A, okay, if we consider go to with capital letter A, then it becomes A, then capital A dot. Okay. So, so if you consider the states, so whenever you find dot at the last end, then they refers, these are our final items. Okay, so I1, then I5, then I6, then I4. These are all final items where we don't have to do anything. Okay. So once we have this BFA, then we can create the table. So in the table, what we're going to have is we're going to have the states. So in this example, how many states we have? I know 2, 6. So we have 7 states. Okay, I know 2, I6. And then here we're going to have some uh, column that is action and go to. Okay. So action is going to contain the terminals and go to is going to contain the variables or non-terminals. Okay. So what are the non? So here I have just rewrite the given production. So what is our production? This is our production, and I just rewrote it over here, where I just place put a number to it. So the first production is S implies to A. Second production is capital A implies to small letter A, capital A. Then A implies to B. Okay, this is the another production. Okay. So so here in action, what we have to place? We have to place terminals. So what are the terminals? We have A, B, and okay, we are to this order. So here, as I mentioned before, you need to understand how to find fast and follow. Yeah. For this particular problem, or from remaining over from here, fast and follow is going to be used frequently. So you need to understand how you can find the fast and follow. So, uh, so this is in action we have our terminal that is A, B, and dollar, and in go to we have our terminal. Terminal is A and S. Okay, we just place it over here. So, mm, so looking to the state. Okay, if you look at the state I node, okay, if you look to the state I node, and if you consider small letter A, B, and dollar, where do you find the state? I mean the region. If you so if you consider the I node and if you consider A, it points to the state I3. Okay, so we are going to refer to the 3. So we are going to use the function as shift. So if you find this small letter A, then you're going to carry it out shift 3 to this state. So we're going to place S3. So S refers to shift. We're going to carry out the shift uh, step over here. And if you consider B, it refers to 4. So S4. Okay. So we shift to the region 4 or state 4. And if you consider A, okay, so if you consider A, then the production, that is fast production over here, is what? Fast production is S implies to AA. It refers, just a second. Wait. Okay. So when we're talking about A, then it goes to the state 2. So we just uh, give A with state 2, and if we're talking about S, then we go to the state 1. So we place it 1 over here. Okay. Similarly, if we consider about with I1, there is no other go to from here, so nothing has to be placed. But in, as there is nothing, we have this dollar where we can say, have a special one, that is exif. Okay, so for augmented grammar, okay, so wherever you find this augmented grammar, this is our form of augmented grammar. So here we just place our exif. Okay, and if we consider about I2 from I2, okay, so if you consider I2 to A means we go to the step 3. So small letter A means to 3, so we just place S3. Okay, and if it goes to 4, then for B S4. And if we consider about capital letter A, it goes to 5, so we place go to 5. Similarly with I3 as well. Okay, now till I3 everything is same with LR0 parsing table. Only like the reduce section we are going to uh, have a different one from the LR0 parsing table. Okay, so as mentioned before, when we are talking about shift, uh, uh, when we are talking about reduce in LR0 item, it doesn't go look for any overhead, so it gives the reduce to all the variables or all the terminals. But in SLR1, we need to check the next element, so we're going to find the follow of the right hand side of the production. Okay. So if you consider the 4, that is I4. So I4, okay, for I4 we need to check the follow of A. So wherever the follow of A is there, we're going to reduce it. Okay. So this is similar to LR0, but only difference is we need to find. So what if you consider this one? What is the follow of A? So follow of A is what? Follow of A is going to be uh, fast of S, that is dollar. Then for then small letter A and small letter B. Okay. These are all follow of A. So follow of A is going to be A, B, and dollar. So in all place we are going to place reduce rate. Okay. And for five, we have to see the production one. Okay. So we have to see what is our follow of S. Follow of S is nothing but dollar. Okay. Follow of for, for the first one, for the uh, step 4, we have to find the follow of A, that is A, B, and dollar. So we're going to place the uh, reduce to all the variable. And for 5, where we consider the production number 1, we are going to do the follow of S. So follow of S is nothing but dollar. So we're just going to place the reduce to only to that particular follow. So dollar. So here 3 refers to the production 3 of your. So R3 means reduce to this production. Okay, reduce to this production. Production number 3, in this case A implies B. Okay. Then R1 means S implies AA. And if you consider for the I6 or the stage 6, it refers to the production number 2. So production number 2 is this 2. So we have to find the follow of your left hand side, that is A, left hand side. Okay. So follow of A is nothing but A, B, and dollar. So we're going to place the reduce to all the terminals as well. So in this manner, we can create the SLR1 table. So if you have doubt, just tell me. And there's one more example. You can just go through it. Okay? If you have doubt, we can discuss again. So meanwhile, just give your attendance. Just so just see if you don't understand, just tell me. Right? Rule number 1.